Oops, I think I made a boo-boo and I forgot the negative on the last one. There you go. Should have been negative 1/9. Okay, so moving on, I want to do the same thing for the next one. So I need f of x minus f of c, and I'm doing the limit as x approaches c. In this case, that's -4. And then my f of x, of course, is given to me. So here's f of x minus, remember, it's f of x minus f of c on top. So f of c would be, let's see, 16 plus 32 is 48 plus 9 is 57, I hope, over x minus c, but that's going to be a plus 4. And so you can see I have a problem. I can't plug in -4 because it'll cause it to be 0. So I got to do some simplifying on top. So there I did some simplifying, combine like terms, and then I went, oh my gosh, I can totally factor that. And now that I've factored it, look, magic happens. It took care of my problem. Now I can plug in -4, so I'll have -4 minus 12, which is -16. Awesome! So on this next problem, I got to figure out all the places where the derivative is undefined. Remember, derivative means I am finding the limit as I approach some value because I want to find the slope there, and that involves taking the limit. So it's going to be undefined at this left dot because I cannot swoop in on it. It's going to be undefined at this right dot because I cannot swoop in on it. So right now I got two values. Then I also have these sharp cusps where the slope would be undefined, the slope of the tangent, if I were to draw it in, because I'd get a vertical tangent. So in addition to those, it's undefined at x equals 2 and undefined at x equals 5. So now I got to figure out what the derivative is at 6. Remember, derivative is slope. So I'm looking for the slope when x is 6, if I were to draw a tangent line there. Well, since it's a line, that's kind of a no-brainer because the slope of a line is constant all along it. And since I have 2 points on that line, 5, 2, and 8, 4, I can simply use my slope formula. So subtract the y's, subtract the x's, and I get a slope of 2/3. So simple. So now's where we're going to start to mess with your head a little, and that you're going to start to see graphs that show slopes. So this is a graph of G prime. G prime is slopes. So when I look at A, it wants to know what G prime of 0 is. So of course my x value is 0, and this is the G prime graph. So I want to know what's the y value when G prime is taking an x value of 0. So I look, and it looks like it's probably about, it would help if there were some actual values on here. Well, actually, I guess there are, because down at the bottom of the y value, it shows -6 down here. So that looks like it's probably about halfway. So I would say about -3. And then it wants to know what's G prime of 3. So again, I'm looking at when is my x value 3. And since out here is 6, looks like 3 is about here, and oh, it looks like if I followed that all the way up, that the y value would be 6. So before we answer the next question, I want to actually study this graph and talk about what it is that we see. Remember, G prime represents slopes. So here's what I notice, is that the y values for G prime are positive from -infinity, because that thing technically goes forever, until probably about, I'd say that's about -2. So the slopes, aka G prime, are positive from -infinity to -2. And then G prime is also positive. In other words, the y values are all positive over on this side of the graph, which looks like from 2 to infinity.